Hello students, welcome back to the lecture series of differentiability, and this is our lecture number 2. Today we will discuss some related problems of the chapter differentiability. So let us go through the video. This is our first question for today's class. Examine the differentiability of some function will be given here. Differentiability at x is equal to 0 and x is equal to 1 of the function, and the function you have is this one. This is your function, and we are to check the differentiability at x is equal to 0 and x is equal to 1. 2 points you see, this point 0 and the point 1. These 2 points are the points of separation or points of change of format of the function. You see here, because less than 0 fx this one, greater than 0 fx is x square, and in the similar manner less than 1 fx is x square, and greater than 1 for x greater than 1 fx is equal to this one. So these are the two possible points of discontinuity and not differentiability. So first of all, we will check the differentiability of this function at the point x is equal to 0 for this point. So we write, we have x is equal to 0 at the point x is equal to 0. So differentiability check by the way of finding the left hand derivative and the right hand derivative, mean L f dash and R f dash. The point is 0 here, so we take L f dash 0 and R f dash 0. You see here, L f dash 0 mean left hand derivative of the function fx at the point x is equal to 0 will be is equal to, this is the definition of differentiability. You already know this. So x tending to 0 minus is for the left hand limit, and fx minus, it is actually fa, but here point is 0, so f0 divided by x minus 0. So that is equal to this one, limit x tends to 0 minus means less than 0, and so fx is equal to, you see here, less than 0, so fx is equal to minus x here, and f0 mean x equal 0, direct equal 0. So equal 0 is in this line, you see x is equal to 0 here. So replace x is equal to 0 in the definition. So f0 will be equal to 0 square, and that is obviously 0, divided by x minus 0 is 0. So x and x is cancelled, so we will have only minus 1, and this minus 1 is a constant number, so need not to convert this limit in terms of h, so it is simply equal to minus 1. Similarly, you find R f dash 0. So this is R f dash 0, this time slight different, it is just 0 plus, and fx minus f0 all are same thing, is equal to 0 plus, here x tends to 0 plus, fx will be this time greater than 0. X tends to 0 plus mean x should be taken as greater than 0, mean this line, because here x is less than 0 and here x is greater than 0. So we take fx is equal to x square, this is x square, and 0 plus remaining same, f0 is already 0, divided by x minus 0 is x, so one of the x will be cancelled, it is remaining only x. Then converting to h, it is h tends to 0, so x should be replaced by 0 plus this new variable h, this is 0 plus h, and using h tends to 0, it is simply 0. So obviously you see the left hand derivative is equal to minus 1 and the right hand derivative is equal to 0, they are unequal. So L f dash 0 not equal R f dash 0. So since they are unequal, mean the function is not differentiable. So the function is not differentiable at x is equal to 0. So this is the first part. Now we check the differentiability at x is equal to 1. Similar method. This is our function. Function is this one. Do not write in your copy now, because it is already written in your copy. So now at x is equal to 1, so here also L f dash 1 and R f dash 1. You see L f dash 1, x tends to 1 minus, this is the definition, fx minus, this time f1 because the point is 1, f1 divided by x minus 1 here. Actually x minus a, it is fa. So x minus a is 1, so x minus 1, it is f1. X tends to 1 minus, you sincerely see here, x tends to 1 minus or x tends to 1 minus mean x is less than 1, and here is x less than 1. So fx is equal to x square. I am writing here x square, and minus f1. F1 means x is exactly equal to 1. So you here search here, you see x is exactly equal to 1. So in that case fx is equal to x square. So replace just x is equal to 1 in the definition. So f1 will be equal to 1 square, and 1 square is 1. Then it is x minus 1. Factorize this, x plus 1 into x minus 1. So x minus 1 will be cancelled out, x plus 1 will remain. You got my point? This is actually x plus 1 into x minus 1. So x minus 1 is cancelled, x plus 1 is remaining. Then make it h tends to 0. So x will be replaced by 1 minus h. This is 1 minus h, plus 1 is already here, h is 0. So 1 plus this one is equal to 2, because h is 0. So 1 plus 1 will be equal to 2. So our left hand derivative at 1 is equal to 2. Then right hand derivative at 1, r f dash 1. So this time x tends to 1 plus, definition will be remain same, x tends to 1 plus mean x is greater than 1, and here x is greater than 1. So fx is equal to x cube minus x plus 1. So x cube minus x plus 1 minus f1. F1 is obviously 1 divided by x minus 1. This positive negative 1 is cancelled. One of the x's can be taken common. You see, x tends to 1 plus x into x square minus 1 divided by x minus 1. This one is already cancelled. So this is x plus 1 into x minus 1. So x minus 1 will be again cancelled, and so x into x plus 1 will remain there. Now make it h. So h tends to 0. X will be equal to 1 plus h. This one. This x is equal to 1 plus h. This plus 1 is already there. Then replace h 0, here 0, here 0. So it is 1 into 1 plus 1, 2. So 2. So right hand limit is also is equal to 2. Left hand limit is already 2. So they are equal, mean the function is differentiable. So LF dash 1 is equal to RF dash 1, therefore the function is differentiable at x is equal to 1. So you may see the graph of the function. Actually in the question it is not necessary to draw the graph, but for better understanding just I am taking the graph. In your exam in general these types of graph are not asked, but if you have the knowledge about the graph it will be better for you. So you see this graph, very simple. When x is less than 0, fx is minus x, fx is minus x, less than 0 here. So less than 0 mean these values, x less than 0, then fx is equal to minus x. So if you take x is minus 1, then fx is also x is minus 1, fx is minus of minus 1 is 1. Say x is minus 2, fx is 2, x is minus 3, fx is 3, and so on. You may take also the intermediate value, 1 minus 1.5 can also be taken. Then minus 1.5 is in that case fx is simply 1.5, and in that way. So ultimately I am telling you that fx is equal to minus x is a straight line with negative slope. This one, straight line. And at the point 0 we already proved that at the point 0 the function is not differentiable. So in the previous class I told you that when a function is not differentiable at some point, there must be a sharp point or sharp turn in the graph of the function. You see this at the point this, when x is equal to 0 here, then fx is equal to 0, that means 0 0. Then when you cross the point 0, that is taking the points which are greater than 0, the values of x which are greater than 0, but up to which point? Up to 1 point, from 0 up to 1 here. It is x square, so it will be a parabolic graph. Actually you see here I am writing this, it will be a parabola because y is equal to x square is a quadratic curve, and you know quadratic curve is always a parabola. You see here, just 1 minute. You see here it is a parabola. Actually a parabola is of the form like this. You see here, very simple. It is actually this graph, it is actually like this. বেশি এটা ভাল নহল তোমালোকে অলপ বুজি লবা, it is like this actually, এনে ধৰণৰ হ'ব। but this parabola is not valid for x less than 0 and for x greater than 1. so সেই কারণে x greater than 1 এর কারণে আমার গ্রাফটো বেলেগ আৰু x less than 0 এর কারণে গ্রাফটো বেলেগ, জাস্ট এই পোরশনটো মই লব লাগে। তো ক্লিয়ার হৈছে মোৰ মতে। জাস্ট এ মিনিট, মোৰ পেন পেপাৰ নাইতো, মই সেই কাৰণে অলপ অসুবিধা পাওঁ, পিছৰ ফালে এইবিলাক হৈ যাব নিশ্চয়। তাৰমানে ৰাইটিং পেডটো থাকিলে অলপ বেছি ভালকৈ তোমাক দেখুৱাই দিব পাৰিলেহেঁতেন। অ'কে, তথাপি বুজি পাইছা নিশ্চয়। চ' দিছ পৰ্চন ইজ পেৰাবোলা। চ' পেৰাবোলা ইজ দিছ পাৰ্ট, বাট হুৱেন উই pass the point 1, mean greater than 1 values of x, then you are to take fx is equal to this one, and that graph is this. For x greater than 1, it is a cubic graph. But here you see at this point 1 there is no sharp turn on the graph, but here there is a sharp turn coming like this and then sharp turn, but here it is smooth, and that is why at the point 1 the function is differentiable and at the point 0 the function is not differentiable. You may also check the continuity of this function. Continuity, it is continuous because you see from the graph here no gap is there, here no gap is there, so it is a continuous graph. You may check that one also. Okay, so this completes the solution of the problem. We take the next new question, and it is for homework for you. You see, examine the differentiability of f at x is equal to 1 and x is equal to 2, and if the function is given here, you see this is your function. Method is similar to the previous problem, so I think you can solve this problem. Now we take this question. If fx is equal to this one is differentiable at x is equal to 1, mean the function is already given that it is a differentiable function. Okay, this is a differentiable function already given, and you are to find the value of a and b. These are the two unknowns, a and b, differentiable, and you are to find the values of a and b. It is one interesting question actually, because you see a and b are in a same line, and a condition is given just differentiable. So by using this condition only, you are to find the values of a and b. Very interesting question. You see the solution. So since the function is differentiable at x is equal to 1, it is given differentiable. So what is the condition of differentiability? So at x is equal to 1 it is differentiable, mean L f-1 and R f-1 are equal and finite value. Okay, so you see L f-1 mean limit x tends to 1 minus fx minus f1 divided by x minus 1, and here also x minus 1 divided by. Similar definition is same, but here x tends to 1 plus and here x tends to 1 minus, mean it is left handed derivative, it is right hand derivative. These are equal and finite because the function is differentiable already given. Okay, now use the values of fx, f1, etc. by the definition given of the function. So limit x tends to 1 minus, you see 1 minus mean less than 1, you see here less than 1. So fx is simply x square right here. F1 mean equal to 1 is again in this line, so replace x by 1, so f1 will be equal to 1 square, that is 1, and x minus 1 is remaining same. Fx here, x is greater than 1 mean this line, so fx will be equal to ax plus b, so ax plus b, and f1 is simply 1 divided by x minus 1. Now try to find the values of these two limits on the equation. So limit x tends to 1 minus, and here the two factors x plus 1 and x minus 1. X minus 1 will cancelled out, so it is only x plus 1, and here it is remaining same, x plus b minus 1, and then making the limit in terms of h. So h tends to 0, x is replaced by 1 minus h, here 1 minus h, and plus 1, this is h tends to a, this is 1 plus h, then plus b is remaining there, minus 1, this x is 1 plus h and minus 1. Okay, we see the Next line, so left hand side limit is 2 and right hand side can be separate by separating this division. It was h by h is simply a, and this term will remain separate. I mean, constant term is separating from the variable term actually. But you see, the left hand limit is a finite value 2, but at the right hand side, you see, right hand side, this a is already valid, but this limit, you see, this limit is not valid because this h cannot be cancelled in any case here. But since the left hand limit is left hand derivative is 2 and right hand side must be a finite value, because 2 is equal to infinite number is not possible, so right hand side must be a finite number, and this is finite only when this limit is finite or this limit is exist. And you see, this limit will exist when and only when this numerator is equal to 0, because 0 divided by h will give us limit of 0, and that is will be equal to 0, and 0 is a valid number, finite number. So this equation 1 will be valid when and only when this limit is 0, and this limit will be 0 only when the numerator is equal to 0. So we write that line only. This is possible only when a plus b minus 1 is equal to 0. So using a plus b minus 1 is equal to 0 in equation 1, so 1 implies this is 0, so 0 plus a is a equal to 2. So we got the value of a as equal to 2. Then using this value of a in equation 2, you will get the value of b also. So 2 implies this is 2 plus b minus 1 is equal to 0. So b will be equal to simply minus 1. And that is the solution for the question. And sometimes for this question may ask what is the value of f-1. Sometimes it may also ask in the question that what is the value of f-1, like this. What is the value of f-1? If this question asked with the problem, then what you will write? Jodi tumak khudhe, so what is the value of f-1? Ekhini to thakiboi. And if this question is also asked, so what is the value of f-1? Then you should write f-1 is equal to what? You see here, this line, this line. What is actually, this is L-f-1 and this total line is R-f-1. So since the differentiation is valid, function is differentiable, mean both are equal. So f-1 should be taken as equal to 2. So if that question is asked, you write f-x is equal to f-1 is equal to 2. You got my point? But in this question it is not asking here. Okay, so just I am erasing this. Just wait. Okay, so let me take the next question. Similar type question, you see, if f(x) is equal to, this is your question, is continuous and differentiable. Function is continuous and differentiable, both continuous and differentiable, at x is equal to 0, then find the values of a and b. It is slightly easier than the previous question because function is given continuous and given differentiable. So both the conditions you can use here. So since it is continuous, mean left hand limit is equal to right hand limit. So there will be one equation involving a and b. And similarly, it is also differentiable at x is equal to 0. Therefore, L(f'0) is equal to R(f'0). And there will also be another equation. And from using these two equations, you can find the value of a and b obviously. Okay, so very simple question. Since the function is continuous at x is equal to 0, therefore limit x tends to 0 minus fx, limit x tends to 0 plus fx. This is left hand limit, this is right hand limit. Must be equal because the function is continuous. Now use the values of fx. 0 minus less than 0. So fx is this line, and 0 plus greater than 0, fx is this line. So you just write that one. Okay, then convert it in terms of h. So simple, 0 minus h in place of x, this is, and here 0 plus h in terms in place of x. Okay, then using h0, so this is 0, this is 0, so left hand side is obviously 0, and right hand side this is 0, so 0 plus b is b. So simply b is equal to 0. Already you obtained the value of b. Now use the second condition, mean the function is differentiable. So again the function is differentiable at x is equal to 0. So therefore this time LF-1 is LF-0 is equal to RF-0. We write that. This is the function given. Do not write this. So LF-0 mean this one, and RF-0 mean this one. This is the differentiability theorem. Differentiability theorem. So fx minus f0, x minus f0. Less than 0 mean this is x square plus 2x. You write this line. X tends to 0 minus less than 0. So fx is equal to x square plus 2x. And f0 mean this one, x is equal to 0. So use x is equal to 0 here. f0 will be equal to 0 square plus 2 into 0 mean total term is 0. So I am not writing here, actually f0 is equal to 0 and x minus 0 is 0. Taking x is common, sorry, that will be the next line. And here x tends to 1 plus 0 plus mean greater than 0. So fx is ax plus b, this one. f0 is 0, not writing here. X minus 0 is 0. X minus 0 is x. Then taking x common and cancelled, you will have this line. X tends to 0 minus, it is x plus 2 only, and on the right side b is already 0. In the previous screen you already obtained that the value of b is equal to 0, and then x is cancelled, so it is only a. So right hand side is a constant number, so it is a only, and here using the limit h tends to 0, it is x is 0 minus h and plus 2. On the right hand side it is simply a, so a will be equal to 2. So we have the values a is equal to 2 and b is equal to 0 only, and this completes the solution of the problem. This is our new question. Let fx is equal to x mod x for all x is belongs to R. Discuss the differentiability at x is equal to 0. A very simple question. First of all, you make this function without the modulus sign, that is removing the modulus sign, and after that you just set the differentiability at the point 0. Very simple, you see. Here the function is fx is equal to x mod x. So fx is equal to x mod x, and x is belongs to R, mean x may be less than 0 and x may be greater than 0. I am taking the point 0. Why? Because this mod is only x. So if you consider this is equal to 0, then the value of x will be equal to 0. That means in the graph of the function there may be a possibility of a sharp point at the point x is equal to 0. There may be a sharp turn at x is equal to 0, because here inside modulus number is x, and that is taken as is equal to 0, and from there you will get x is equal to 0 only. So therefore x is equal to 0 may be a possible point of sharp turn in the graph of a function. That is why I am taking the point 0. Less than 0 and greater than 0, combining all values you can obtain this x belongs to R. So less than 0, less than or equal to, equal sign may be taken here also. Do not confuse with that. And then x is less than 0, then mod x is equal to minus x. We all know this one. And x is greater than 0, then mod x is equal to x by the definition of modulus function. Then it is actually what? Fx is equal to, this is minus x square for x is less than 0, and it is x square for x greater than 0. Okay, so then you check the differentiability at x is equal to 0. You see LF-0, because differentiability should be checked at the point x is equal to 0. So LF-0 is equal to x tends to 0 minus, this is definition of differentiability, fx minus f0 divided by x minus 0. X tends to 0 minus mean less than 0 is this line, minus x square, equal 0 is this line again, so minus 0 square is equal to 0, and divided by x minus 0 is x only. Cancelling this, it is minus x, so then making h tends to 0, and so minus h, x is 0 minus h. and using h tends to 0, 0 here, only 0. So left hand derivative is equal to 0. Then come to right hand derivative, similar method, okay, but this time fx should be taken as this line, greater than 0, this line, okay. Rest of things you can understand. So they are equal, mean function is differentiable. Therefore left hand derivative mean lf dash 0 is equal to rf dash 0. Therefore the function is differentiable at x is equal to 0. So I think you understood this question. Next come to a new question. Examine the differentiability of f where f is defined by, this is the function fx is equal to x. It is the symbol of greatest integer function x when x is between 0 and 2, and this is the another definition of function when x is belongs to from 2 up to 3, mean the closed half closed interval 2 3, okay. At x is equal to 2, the point is 2, given point is 2, and you are to check the differentiability at x is equal to 2. Similar method, just function is greatest integer, and if you have the knowledge about the greatest integer function, the problem is not tough question, it is a very simple question. You see, to check at x is equal to 2, lf dash 2 and rf dash 2, you see. So lf dash 2, x tends to 2 minus, function derivative definition is this one, this is differentiability definition, x tends to 2 minus, mean less than 2, less than 2 is here, x is less than 2, so fx is x greatest integer x, this one, and minus f2 is equal line is here, x is equal to 2, so it is 2 minus 1 into 2, mean 2 minus 1 is minus, it is 2 minus 1 is 1 into this 2 minus 1 and into 2, so 1 into 2 is 2 simply, okay, simply 2. But you see, making h tends to 0, h tends to 0, x is equal to 2 minus h, this 2 minus h, 2 minus h, minus 2, and the denominator is x is equal to 2 minus h minus 2. This positive negative h 2 is cancelled, minus h is the denominator, but here you see this interesting point is here, interesting point is here, this one, this is interesting. Actually this is what type of number, 2 minus, you see h tends to 0 mean it is a very small number. So let us consider the small number as 0 point, some huge number of zeros after the decimal point, then say it is 1. 2 minus 0.00000, then 1, and greatest integer of this, what will be this? So this is simply you see 1 point, it is 1 point, is it not, 9 9 9 and so on, greatest integer of 1.9999 like this, and greatest integer of 1.99 will be equal to simply 1, is not it? You know that one. So I am erasing here, just wait, I am really sorry. Okay, so you see this 2 minus h will be remain same, but this greatest integer 2 minus h will be equal to 1, and this is 2 remaining same, denominator is minus h because 2 negative 2 is cancelled, so this is 2 and negative 2 is cancelled, minus h will be there, cancel 1, so the left hand derivative at 2 is equal to 1, then find right hand derivative 2 plus fx minus f2 divided by x minus 2, this is 2 plus fx will be equal to, this was our function, 2 plus mean greater than 2, this line, so fx is equal to x minus 1 then into x. F1 is similar to the f1, not f1, f2 is this 2 minus 1 into 2, this one, by x minus 2, then completing this product x square minus x, and this total result is minus 2, this is x minus 2, limit x tends to 2 plus, factorizing this, x minus 2 is cancelled, so limit x tends to 2 plus, x plus 1 is remaining here, making h tends to 0, so x is replaced by 2 plus h, then plus 1 is there, and using h0 it will be equal to And so we see that the left hand derivative is not equal to the right hand derivative at x is equal to 2, and hence this function is not differentiable at x is equal to 1. So hence the function is not differentiable at x is equal to 2, not 1, sorry. So this completes the solution of the problem. Okay, so next we take another question, this one. If fx is equal to, this is your function given, show that fx is continuous but not differentiable at x is equal to 0. So continuous but not differentiable, there are two questions actually. So continuity part mean left hand limit and right hand limit, they should be unequal, and differentiability is left hand derivative, right hand derivative should be unequal. You see the solution. At x is equal to 0, left hand limit x tends to 0 minus, function is fx, limit x tends to 0 minus, 0 minus mean less than 0, mean not equal to 0, therefore fx is this line here. Then making h 0, you know this 0 minus h, but 1 by x, x is replaced by 0 minus h is minus h, so it is simply minus 1 by h. Just all of short korisu moi, tumi buji laba, and it is 0 minus of minus h is 1 by h, here e to the power minus 1 by h, it is 1 by h. Then dividing by 1 by h here, because if you directly use the limit, this will be 0 but this will be infinite. This is 0, this is infinite. How it is 0, you know this one. It is 0 is discussed in the continuity chapter. So dividing by e to the power 1 by h, limit h tends to 0, this is minus h, e to the power 1 by h, so it will be e to the power minus 2 by h, minus 1, e to the power minus 2 by h, plus 1, and so this is 0, minus 1, this is 0, plus 1, minus h is already there, 0 into some number is equal to 0. Then right hand limit is similar like this, this time h tends to 0, so x is replaced by 0 plus h, and 0 plus h is simply h, here also 0 plus h, 0 plus h. But if you use the limit here, this is infinite, this is 0, this is infinite, this is 0, but you can divide by this e to the power 1 by h here. So e to the power 1 by h division, h is here, it will be 1 minus e to the power minus 2 by h, 1 plus e to the power minus 2 by h. So 0 is here, this will be 0, this is 0 after using the limit. So 1 minus 0 divided by 1 plus 0, and 0 into this. So 0 into some number is equal to 0. Left hand limit is equal to 0, right hand limit is equal to 0, and you see the definition of the function given. You see f0 mean at x is equal to 0, function is also equal to 0. So f0 is also equal to 0. Therefore left hand limit, right hand limit and function value all are equal. So the function is continuous at x is equal to 0. So thus the function is continuous at x is equal to 0, and this is the first part of the problem. Now we find the differentiability section. So again, L f dash 0 definition is this one, differentiability definition, fx minus f0. So fx is x tends to 0 minus mean x less than 0, and less than 0 is also x not is equal to 0. So function will be taken as this one. f0 is already given 0 divided by x, this x is cancelled, so we have only this part remaining. Okay, then similar method as in the limit section, making h tends to 0, then it is minus h like this, then making this 1 by dividing e to the power 1 by h in the numerator and denominator, it will be 1, it will be 1, this is e to the power minus 2 by h, e to the power minus 2 by h, using the limit 0 minus 1, 0 plus 1 will be equal to 1 only, minus 1 only. Then right hand limit, right hand derivative, similar, definition is similar, 0 plus mean x greater than 0, x greater than 0 also is x not equal to 0, so fx is this line again, this one, f0 is obviously 0 given in the question, x minus 0 is x, then again x is cancelled, this is remaining now. Again making h 0, this time it is 0 plus h mean h only, here also 0 plus h, okay, then making this 1 by dividing e to the power 1 by h in the numerator and denominator, so 1 minus e to the power minus 2 by h, here 1 plus e to the power minus 2 by h, So this will be 0 after putting the limit. So 1 minus 0 divided by 1 plus 0 will be equal to 1 only. And you see the left hand derivative is minus 1 and right hand derivative is equal to 1. So therefore the function is not differentiable at x is equal to 1. So this completes the solution of the problem. And we finish this video here. And in the next class we will begin the chapter differentiation. Differentiation means methods of differentiation. There are so many methods: use of chain rule, then use of logarithm, exponential function, then function to the power function differentiation. Some special questions are also there. In the next class we will just begin the chapter use of chain rule. And in the first year we already discussed a slide about the chain rule of function, and in the next class we will just solve some related problems of chain rule only. Okay, that is differentiation of composite function. Differentiation of composite function. Composite function means function of function where the chain rule is used. Okay, so in the next class we will do some problems of chain rule. And you are already familiar with the chain rule, so we just solve some questions. There will be no theory part of the chapter. And in the next classes, subsequent classes, we will discuss the differentiation methods given in your books, and some special problems will also be given in the final classes of this total series. Okay, so for today, thank you very much.